Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Imran Hakim bin Rasmadi. My group is consisting of me, Muhammad Amin Aziz, Lohyu Chong, and this is our project code. So I'll be explaining the first third of the code of our code. So in data, we can see that we have perkataan byte 10 duplicate 0. So this variable will be the one to store our input for our 4-digit hex in terms of a character array. So count the word will store the length of a character array. Max 50 is the initialized size for the input string right here, plus 1 because we want to plus 1 because we want to input the include the null. So this input string will be for when the user is prompt, I want to try again, yes or no. They can input y, n, or something else. But if they input something else, something error will happen. We program in. So this is test 1, test 2. This is to test if the end user is entered y, n, or something else. So these are the prompts are the one that will prompt the user for input or just display on the console. So here, so prompt 6, the user will get when they enter the wrong hexadecimal digit or wrong input of hex, or they when x try again prompt 5, they enter something else other than y or n. So the carry bit byte will check if there is a propagation or not. So moving down to min proc, in while 1 we can see that the move edx offset from 1. So the address of from 1 is moved to edx, so it can be called write string. So they will output please enter a 4-digit hexadecimal integer in the console. Then we move offset perkataan into edx. So perkataan will refer to our input, the place variable where we want to input our hex digit. Then the size of perkataan will be moved into ecx, the counter. So then we will call read string to input into perkataan, then move eax into count size also. So then we move offset prompt 2 into edx and then call write string. So prompt 2 is 2's complement of hex is such and such. So we move edx perkataan, call write string. So it will output the complement of hex input such and such of the user's input. Then offset, it will move edx with offset prompt 3, which is. So 2's complement of hex input such and such is, and then it will output onto the console. This is for in case that the user inputs a lower letter case, and so we will automatically change it to uppercase. So the offset perkataan, the starting of the address of first member of perkataan will be moved into ECASI, and the counter of 3 will be moved into ECX. So that's my part explained. So I will run a test run. Oops, we'll build it. Okay, let's enter code A1B2. So the 2 complement of hex A1B2 is 5E 4E hex. So do I want to try again? Yes. So let's try another input, A0BC. So the 2's complement of hex A0BC is 544. So let's try yes again, but we try to input something else. So let's say add AZ67. So it will say the 2 complements of hex AZ67 is error. So let's try again. Let's try if it's a lowercase. A87. So it will it prints out the output because the 2 complement of hex A87, but inside the code it will convert the small letter case A into a capital letter. So let's say I want to try again, but I input something else. Let's say T. So you enter wrong code. Please enter carefully. So press enter to continue. Want to try again? Yes. Okay. So let's try again. A D 3 4. So we get it. So do you want to try again? No. So press enter to continue. Then we're done. Thank you very much. Okay, after doing this group project with my group members, I've gained a lot of knowledge. Especially first of all, some beforehand I've learned about the ASCII values and how that the computers know identify a character A, B, C, capital A, asterisk, hashtag by a predefined value with its own predefined value of numbers. So a certain number may refer to a specific character, and then not only so after learning that, in this project I have learned how to apply that knowledge into solving our problem and solving the question. Not only that, I also learned that I have also managed to apply all that I have learned beforehand in the COA subject and apply it into this one project code. And you can see how each thing that I have learned comes together into and melts into a perfect code. Okay, thank you for listening.
Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Muhammad Amin Haziq bin Hisham and I am from section 2. My metric number is A19EC0087 and then today I want to continue my Imran's part. Imran's part is up here, so I will continue from this. Okay, first is move ESI offset perkataan. So it will store the address of the first member of perkataan. So for example, user input A O B C, right? So the first member is A. So it will store in ESI. So okay, and then next we move to the ECX3. ECX3. Okay, later I will discuss about it. Okay, first complement. Move AL. AL is the lowest bit. AX and then we have AH and then AL, right? So AL we use byte PTR ESI plus ECX to make the stack value. Okay, ESI is the refer to the first value of perkataan, right? And then ECX ECX is for the location of the ESI using Little Indian as we using it in byte. So I want to show you. It is more just like this. Okay. When user input the first is A and then O B C, right? Okay, A will okay, ESI plus 3 will hold the value of A and then I will decrease the value of 3 into 2 1 0 decrease by 1 because we use byte, right? So ESI plus 2 and then ESI plus 1 then ESI plus 0 nothing. Okay, okay, this is the orientation of the stack, and then when integer are loaded from the memory into memory to register, the byte are automatically reverse to their correct position. So the value is the output will give the correct value. Alright, next we move to the Okay, this. Compare AL with 53. Okay, 53 is what? 53 is a decimal value, right? But AL, just now we use the character in ASCII table. So okay, 53. If we look at in this ASCII table, 53 is 5. This is how to check decimal 53, and then convert to char is 5. Okay, and then we compare it. Okay, if AL is greater than 53, if AL is greater than 53, we will do this jump first complement number, so it will go to this, jump to this. If AL is less than, it will keep doing this. So okay, sub AL with 48. Sub AL with 48. 48 is the 0 in the ASCII table. 0 in ASCII table. And then subtract. Okay. Why we need to subtract with 48? Because we want to know the distance between the two value of the user input. Okay. And then move BL with 70. 70 in ASCII table is F. So okay, now BL hold the value of F, right? And then sub the F with AL. So okay, and then okay, if we know the, and then sub AL is 48. Okay, if we know the distance between the two value, and then we subtract with BL, and then we will get the first complement. Okay, for example 78. For example, okay, let we just pick one number here. We put 52. We get a 52, right? Okay, 52 is not less than is not JBE, so it will do this. Okay, if we take 52, and then we minus with 48, it will result 4. 4 is the distance between the two value, and then AL hold 4, and then 70 minus 4. 70 minus here 70 minus with 4, it will get 66. So the newest value of BL is 66. Here 66, we refer to this back. 66 is B, which is the result of the first complement of 4. Alright. Alright. Okay, jump. Okay, after we result the first complement, get the first complement, and then we will do the next step. Next step is two's complement. Two's complement we will add with 1. So jump plus. Okay, it will skip this and then go to jump plus here. Okay, but later. Okay, next we move to the first complement of number. First complement number. Okay, what is the difference between first complement of number and first complement this? Okay, later I will discuss it. Okay, compare AL with 57. 57 is the value 57 je. 57 is 9. Okay, 57 is 9. Compare AL with 57. Okay, jump above. If the value is above 57, it will jump above first complement to alphabet. Yeah, because when you see this 57, if greater than 57, it will goes to here. Alphabet things. A, B, C, which is consists in hexadecimal number. Okay. Okay, for the cases that the number is not too high, not more than 57, it will do this sub AL with 54. 54 is 6. Okay, it will continue the 6 part. This. Okay, because I do this subtraction because I want to know the distance. Just like I said in this first complement, it just use the same action. Okay, move BL with 57. Okay, this is for the temporary. 57 is 9, right? So sub BL with AL. Sub BL with AL because we want to know the first complement. And then after we get the first complement, we will jump to plus. Okay, I will explain why we use first complement and then first complement number. Okay, this one actually is for the lower number, which is lower than 5 lah. And then this is the greater than 5. Okay, because here is some notation. Save. Okay, if the value is 0, 1, 2, 3, 4, 5, the first complement, it will get this 0 equals to F. This will become A, this will become to B, this 3 will complement, first complement will become C, D, and E. Okay, this is the complement of the lower number that I use here. First complement here, lower number. It will result this. But if we use the bigger number, just like 6, 7, 8, right? Okay, 6, 7, 8, 9. The first complement will become this. It will result this. Okay, this is the result of this. So that's why I subtract with 54 and then move BL 57. 57 is 9, right? And then we minus and then we get the first complement value. Okay, next first complement alphabet. Okay, first complement alphabet is the we still use this, but we terbalik, upside down. Okay, first compare AL with 70. Okay, what is the value of 70? 70 is F. F. And then jump above to exit 2. Jump above. Why jump above? Jump above. If above this 70 value, it will result no hexadecimal. So it will jump to XZ2. XZ2 is what? XZ2 here. XZ2 here will write the string of prom 4. What is prom 4? Prom 4 is this error. Yeah, because no value. It is not hexadecimal value. Alright. Okay, where are we now? Okay, this is the error one. Okay, and then we just use the same sub AL with 65. 65 is A, and then we subtract with A to get the distance of the value, and then move BL with 53. Okay, what is 53? 53 is this 5, and then we subtract, and then we get the value of first complement, just like this. Just like this. If the value is A, and then first complement will become 5. If B, it will become 4. C, it will become 3. That is the first complement work. Alright. Okay, after do the first complement, it will go to jump plus. Okay, here is the plus. Alright. Okay, jump plus. Compare ECX with 3 to check whether the MSB or not, because only add 1 to the MSB. So just now the ECX we use 3, right? If jump not equal, it will go to propagation. If 2, 1, 0, it will jump to propagation. Later the ECX will be updated. Okay, if equal to 3, it will continue this part. Yes, 9. Okay, this is the part where we will test whether it need to plus 1 or not. Okay. Okay, compare BL with 57. Compare BL with 57. What is 57? What is 57? 57 is 9. Okay. 57 is 9. Okay. If not 9, jump not equal to not 9. If the value is 9, it will go here. Okay, why I use... Okay, later I will discuss about it. Okay, for now, if it is 9, the BL, okay, the BL value is this. BL value is 9, right? And then if we plus 1, and then how to do this? So I will use this. Move BL with 65. 65 is this. 65 is A. So when 9 plus 1, it will become A. If you're not sure, you can check in the calculator. Using the hexadecimal base. Then 9 plus 1, it will become A. So the carry bit is 0, because 9 plus 1 is A. So no carry bit. No carry bit. So the carry bit is 0, and then we jump to sambung. Sambung, where is sambung? Okay, here. Later my friend will explain about the sambung. Okay. Okay, where are we now? Okay, not 9. If the value is not 9, then what value? So if the value is 70, if the value is 70, look at here. If the value is 70, F, it is F. If the value is F, jump not equal to F. Jump not equal to F, go to this, not F value. Not F value. If the value is F, move BL 48. Move BL 48. Move the BL with 48. 48 is 0. Okay, and then move carry bit 1. Because when F plus 1, it will become 1, 0. So we have the carry bit. We have the carry bit. Using calculator, hexa base, F plus 1 is, we have the carry bit here, 1. So F1, okay. And then jump to sambung. Okay, not F. Not F is the condition that not 9, not F. So this is the easiest part. So add BL with 1. Simple. Add BL with 1. Add the BL with 1. And nothing to be concerned. No carry bit lah. So we move the carry bit 0. Since the hexa value is not okay, no carry bit. Okay, and then we jump to sambung here. Okay, that's all from me. And then later my friend will explain more about it. Okay, here I want to test when we enter A0B, right? That's 544. And then if we enter 544, no, try again, enter yes. Okay, if we enter AOBC, the hexa, the two's complement is error because we use O here. Okay, try again. Okay, if we enter the wrong code, we use R. And then you enter wrong code, please re-enter carefully. Okay, enter. If you want to, this is the for the confirmation. Yes, if you want to enter, and then blah 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 blah. Okay, the hexa is error. Okay, you want to try again? No, of course not. Okay, I need to continue. Okay, that is for the sample input output. Okay, that's all from me. Oh, wait, for the reflection, in this project, COA project, lab project, I've learned that on how to use the PTR, the PTR function. Where is PTR? I've learned on how to use the PTR function using the stack of the Little Indian, and then I know how to use the ASCII table. Okay, this is my summarization that I made. I am able to use ASCII table in this code, in this COA project, and after that later my friend will explain more lah. Okay, thank you.
Hi doctor, my name is Loy Chong. I'm from section 2. My material number is A19EC0076. Now I'll continue my friend's part after the not F. So propagation. So first of all, I'll compare the carry bit with 0. If it's not equal to 0, so we will go to ES9. So if equal to 0, then we will continue here the sambung. Then first of all, sambung, right? So I will move BL to the pointer here, which is got this okay. Then I decrease the ECX so that I can update the loop counter. Then I compare the ECX with -1, and then when I compare, right, so I use the JE. Okay, jump when equal, when it is equal to -1, so we'll go to XC1, or else it will jump to first complement. Okay, then for XC1, so first of all I move the perkataan, offset of perkataan, and then we go to EDX, and then I write the string out. After that it will be I will new line, and then I will jump to XZ at here. So for the XC2, right, so it is for when the user enter invalid hexadecimal number. So I will move prompt 4, offset prompt 4 to EDX, and then I call print string. Okay, write string, not print string. So it's error at here. Okay, then okay, I write out an line, and then I will jump to EXI. So EXI at here. Okay, then I move prompt 5 to EDX. Okay, actually this is for me to compare whether the user want to enter it again or not. For example, like prompt 5, right? Prompt 5 will ask the user try again or not. Okay, try again. It's y and n. So I got two variables that I will test later. So it will be y and n at here. So it is test 1 and test 2. So here, test 1 and test 2. So come back to here, XC. So first of all, okay, after I write the string out, ask them ready. So for them to enter, right, got space. I will make the space there. So I will put input string of offset of input string to EDX, and then I put max to ECX so that I can enter how many space, how many character. Actually, in this project, we made it to 50. So actually, how much also can run, but cannot too less now because we need to enter, right. So move to ECX, and then I read the string. After that, I invoke string compare with, okay, and I compare the input string that just how people input, and then with the test one. Test one is y. Okay, test whether the character that the user enter is y. Why? Because we use max is 50 because so that maybe yeah, just we just do it like that. Actually, when we want to put a small, so can like 3, so can. Then after that, if it is not equal to y, so it will okay, new line, and it will jump to, well, no, when it is not equal to y, it will go to here, no, it will jump to no. Then if it is equal to y, so it will new line, and then we jump to y1. Then for no, right, after when we compare already, it is not y, so it is probably n or others. So we compare the input string, invoke string compare the input string with the test2. So test2 will be n. So if it is not n, jne, so we will jump to other at here. Okay, then if not, it will new line, and then we will jump to here. Here it will be at here. Okay, so for the other, when the input is not n and also not y lah, because it's 2 times already, right? So new line, and then I will offset move offset prompt 6 to EDX. Prompt 6 what? Prompt 6 is you enter wrong code. Please re-enter carefully. So I will write it out, and then to new line, and then means okay. Then I call wait message. Okay, you will come out like this, and then clear the screen, and then you jump to XC right here. Okay, to let them check again, try again or not, like that. Then will be here. Okay, here is when it is n. So when it's n, so we just call wait message, and then call clear screen, and then we exit. Yeah, I think that's all from me. Okay, from in this project, I learned a lot, basically about how to compare the hexadecimal input, and then how to store them, how to manage them, and then better check about their carry bit, and also use how to use the invoke string compare to compare them. Yeah, I think that's all from me. Thank you, doctor.